team. We got a confirmation.
Oh my God, look at that. Oh yeah! Put that up on the screen. Plenty confirmation, that's right.
It's just erupted in applause.
Good morning and welcome to NASA's Jet Propulsion Laboratory in Pasadena, California, and happy 4th of July. We're here to share with you the exciting news and the images from our very successful deep impact mission to Comet Tempel 1. Joining us tonight this morning, we have Andy Dantzler. He is the director of the Solar System Division at NASA headquarters. Rick Gramier, the Deep Impact Project Manager from the Jet Propulsion Laboratory. Kare Patel, the Deep Impact Deputy Project Manager, also from the Jet Propulsion Laboratory. And Dr. Mike Ahern, the Principal Investigator for the mission from the University of Maryland. But before we begin, I'm going to call up the Director of the Jet Propulsion Laboratory, Dr. Charles Alachi, for some introductory comments.
Well, was it awesome? And I was told that we had more hits tonight than the combination of Cassini and MER put together. So that show you, and it brought the servers down, for a short while. I'm wondering now, there is a comet up in the sky, wondering what in the heck hit it? We said this morning that this was going to be, or this is a daring and risky mission. Well, I can tell you it was. But this dream team from JPL, Ball, University of Maryland, and other universities really made it look easy. And these are the people you see in the white, red, and blue shirts, are sitting in the audience and probably sitting back in the operation room. Now, there is a new trail of exploration for future generation that this team kind of laid out. And what a way to celebrate the 4th of July and the anniversary of our country here. And before I introduce the next speaker, I want to acknowledge two very distinguished guests here. We have Congressman John Culberson, who's sitting there, and we have David Southwood from the European Space Agency. And now I introduce the third. And now I introduce the third VIP, who's not a guest, but he's usually here. He's part of JPL and NASA, Al Diaz.
Well, thanks. And let me also say happy birthday, America. It's great to be here on the West Coast where for the first time in history the fireworks started here. I just wanted to take a second to congratulate the team that made this day possible. It's been a long day, but it's a day that's been the culmination of a long period of effort that a lot of people have made possible. Let me first congratulate the science team led by Mike Ahern for having a great idea, but also having the persistence and patience to make it happen. So congratulations to them. Let me thank and congratulate the NASA centers, not the least of which is JPL for its technological leadership, but also the Kennedy Space Center for its launch, and the other NASA centers for their participation. Let me recognize and congratulate the industry team led by Ball Brothers for the work that they've done producing the hardware that made this day possible, both the spacecraft and the imaging systems. Finally, let me thank all our partners and congratulate them. As has been said before, the science that comes out of this mission will be enabled by an array of dozens of assets that have been pointed at this event, and those assets are controlled by all of our partners, both domestic and international, and it's nice to have David Southwood here from the European Space Agency, who's played such a critical role in making this a success. So congratulations, and thank you all for being here.
We'll start right now with Andy Dantzler.
Thanks. Well, what a smashing success, huh? I can resist. Look, I know that most of you want to hear from the engineers and scientists on the panel. I won't prolong this very long day. I do want to point out that this has been, as the two previous speakers said, quite a success, quite a hit for NASA. Quite a success for teamwork in general, the team of university, NASA Center, NASA headquarters, Ball Aerospace, a wonderful collaboration around the world, including the European Space Agency Rosetta spacecraft. And also, it's quite a success, quite a hit for a program, the Discovery program, that knows how to pick the best of the best. Just in case you missed it, we have a picture of the impact. There it is. That is phenomenal. I was trying to think of how to describe this, and I'm just plain speechless. I know Rick is going to go more into just how close this is to how it was modeled, but I have to say, I don't think anyone expected it to go this beautifully well. So on that high note, I'll stop gushing and pass it off to Rick.
Thanks, Andy. Well, I'm more relaxed than I was the last time I was up here, that's for sure. Give you a little status on the mission. Right now we're -1 spacecraft, the impactor. It's been totally vaporized per plan, and we were right on target, as you've heard, and we have a healthy flyby spacecraft, and Kara will talk to that some more. If I could get the first image, this is kind of an interesting compilation, if we can get the roll. Starts out with the animation video. As you can see, we've shown it many times, and you see the impact here. But what's interesting when you look at this is there's the impact that actually occurred. It came together quite well. Just phenomenal. It went very much like clockwork. We didn't exercise a single contingency plan that we had, and we stepped through everything just like it should have been. If I could get the next roll. What you'll see here, of course, is the team reaction when we actually could confirm that we hit.
Team, we got a confirmation.
This is, I have a fun crew, what can I say? This, you know, to say to the team members out here, just one heck of a job. We couldn't have been here without a lot of teamwork, and my thanks goes out to all the team members who worked very hard, spent a lot of time away from the family, worked a lot of holidays. You guys did a great job, and everybody should applaud you for it. And then, of course, we had to stop celebrating real quick and go back to taking care of the flyby. But what I'd also like to show you next is, if we could get the next roll on here, is actually a bird's eye view from the impactor's viewpoint coming in to the comet. This was just phenomenal as we were coming in and doing the trajectory correction maneuvers of it. And you can see it all the way up to the end. We actually, I seem to remember a previous news conference, we were telling you that we had a requirement to get a picture about 30 seconds out from impact, and what you saw here, we got the last picture was 3 seconds before impact. Just phenomenal. So it was great. I think we've provided the science that Dr. Earn and his team can chew on for quite a while. And with that, I'll turn it over to Kare, the deputy manager, who will talk on the flyby.
Wow. First of all, I want to congratulate and thank the team for an outstanding job for making this happen. We couldn't have done it without them. Flyby is performing amicably. After the separation event, it headed towards the spot where it needed to be to photograph the impact. And once it did so, it went into shield mode for closest approach, and it came out the other side with not a single system damaged. So the flyby is doing great. The first picture that you will see here is the is a picture from the impactor as it's going in, and taken from the ITS camera. And as you saw in the prior video, the impactor went and hit the comet in a specific spot. The flyby's job was to image that spot. And between the two of them, the coordination, we had the spot nailed to less than 50 meters off. So the flyby imaged the spot to within 50 meters of where the impactor hit. So that's just amazing. Can I have the second one, please? This is from the flyby perspective as it's looking and imaging the impactor going in and hitting the comet. So this is just incredible. So with that, Mike, it's all yours.
Thanks. Most of the rest of the team got thanked, but I want to thank Kara and Rick particularly for bringing this across. And we pulled out, I just have a few still images to show you, but I need to tell you that as we were sending the images off to be prepared for this press briefing, we were, of course, still watching the images that were coming down. And there are many more spectacular images yet to be revealed. First, I'll just show you two impactor images, picture of the whole thing. These are in the clip that Rick showed. So there's the whole comet. It's about 5 kilometers across, sort of 7 or 8 kilometers long in this projection, but it rotates around this way, so we're not seeing the full long dimension of it in this picture. The next is one of the close-up images. That picture has a scale of about 7 meters per pixel. The big crater has a diameter of about 1.5 kilometers, something like that. So we've got by far the highest resolution images of a cometary nucleus ever from the impactor, and we haven't, not even counting what we'll get from the flyby. So the impactor was perfect. The flyby instruments also work beautifully. We got tremendous spectra, new spectral features, really strong spectral features, great thermal spectra. I'm not going to show you any of those. They just take too much interpretation. So I'll show you an MRI image of the impact, which is the next still. And the next image shows you what you can do when you start working with the HRI, and you all know the HRI is a little bit out of focus, but you put some deconvolution on it, and you can recover a fair bit of resolution. So we haven't worked out what the resolution is. We finished doing the deconvolution with 1 minute to spare to get the image over here for processing. So the flight team has completed most of its work. We're just basically starting our work now, trying to make sense of what we've learned. Obviously, it was a very big impact. Presumably, we have a large crater in some one of those images that hasn't played back yet. The interpreting the ejectocone, we obviously have lots of images of the ejectocone. Interpreting that's going to take a little bit of time. There are lots of structure in it that's of interest to understanding the nature of the comet. We'll be working that out over the next half day and weeks and months and years. And I just look forward to a wealth of data that will take me to retirement.
All right, we're going to go ahead and start taking questions here. When you raise your hand, would you please wait for me to call on you and get a microphone to you so we can hear your question, and then please state your name and your news organization. Where should we begin?
Brian Cox, BBC. Are you confident you're going to get some good images of the crater? I mean, is that big bright flash going to die down, in your opinion?
So no, we'll have to wait and see. We only have 10% of the data down.
Yeah.
The rest comes down over the next day.
Okay. Bill Harwood, over here. And then again.
Bill Harwood, CBS. So you said, Dr. Hearn, you were still seeing stuff coming in as you walked over here. Is the evolution of the ejecta cone proceeding? Is it dying down? Do you see any trends you can tell us about over, I guess, that 45-minute time scale?
There was still a very good, bright ejecta cone, much larger than the cometary nucleus, in the first look-back imaging, which is 45 minutes later. That much I can tell you. That was the image that came down 5 minutes before we left to come over here.
Gary Robbins.
Gary Robbins at the Orange County Register. From the size of the flash, can you tell anything about the amount of material that was ejected, and is it too early to tell anything about the chemical composition of it?
We've made some crude estimates of the amount of material from the brightness of the flash, but I think we're going to hold them till we think about them a little bit, and we may or may not discuss those at the briefing at 11 o'clock this morning. And the composition, there are unidentified spectral features. Obviously, we can't tell you what they are. Not yet.
Anthony Cabrera with Space.com and Space News. Has any information started coming in yet from Hubble and Spitzer and some of the ground-based telescopes that we're monitoring?
Yeah, they observed a brightness increase of about 2 magnitudes, which corresponds to a factor of 6. Both ground-based and Hubble observed that kind of brightening. A few telescopes reported big increases in the emission lines in the spectrum. So they're getting lots of results also.
Okay, in the back.
Mark Horseman, ABC Television in Australia, and looks like honorary member of the impacted team. Can you tell me, could you have pulled this off without the radio telescopes in Australia?
No, obviously not. We needed the communications, and we've been using those assets all along for quite a while, and in fact almost constantly over the last two or 3 weeks. In addition to that, since this is one of those one-time shots, we wanted to make sure that we had overlapping coverage and made sure that if we had one station, say Madrid or Canberra, that we had them overlap so that we had time for the handoff and not to lose data. So it was very essential that we had this in order to perform the mission and get the data back. And we're still going to be using them to get the data back.
Science aside for a moment, please, gentlemen. What message are you sending to the world by shooting a comet on the 4th of July?
I'll think about that. I don't think we started out to send any message at all, actually. We were actually performing a science mission, and as you can see, and from listening to Dr. Hearn, we have a lot of science to be had here. That being said, I obviously hope that it's made America proud to see that we overcame a lot of challenges. A lot of people said we couldn't do this or wouldn't be able to pull it off, and the team stuck together through a lot of adversity and problems to work out and made it happen, and it happened like clockwork, and I think that's something to be proud of on America's birthday.
Guy Gouy out of the Washington Post. For Rick, could you describe what happened during the 3 course corrections that the impactor made as it made its last approach? How long were they? Did the impactor really need to bother? I mean, were you that much on target, and just how did that go?
Sure. And I'll probably ask Kerr for some help if he remembers all the numbers. But basically, yes, in answer to one of your questions, yes, we did have to bother with it because obviously as we're closing in, the comet's moving too. And as we had briefed before, we didn't know the exact size and shape of this comet and had to do some final adjustments as we were coming in. So the first ITM at 90 minutes out, I believe, was 2-point-something meters per second.
1.26.
Okay, 1.26 meters per second. The next one was, oh, you got it all written down. You're doing good here. 2.2 meters per second. And then the third one,
2.3.
I can't read your writing.
2.3.
Okay, it was 2.3. And that also, from those, after each one was done, then the next cycle would pick up to do the next auto navigation solution, and the result of that would tell us how the first one did, so it then would go and target for the second one. So each time it did one, we got back with the next solution, where it was and how it was getting there. And so obviously our confidence just started increasing, not only as we saw the images getting larger and being pretty much dead on, but we knew that it was making minor adjustments, and we felt pretty good going in those last 30 minutes or so that we were going to have a good day.
David.
David Chandler from New Scientist. For Micah Hearn, I know this is very early, but during the commentary, during the encounter that we heard, Don Yeomans was saying that the size of that plume was very much at the high end of the range of predictions that had been made. Is there anything that you can conclude already from just the sheer size of that plume that was produced? Does that rule out any models or make anything less likely than it was this morning in terms of the structure of the nucleus, its porosity, its density, anything at all?
I haven't even had time to sit down with my cratering experts on the team, so I would be hesitant to speculate, but clearly it rules out really porous structures where you tunnel very deeply, and the impactor just sort of slows down gently, what I refer to as the aerogel capture scenario. So it rules out those kinds of structures without a doubt. I think it probably rules out a strength-dominated cratering, but I need to, before I say any more than that, I'll consult with the cratering experts on the team.
Katie Human from the Denver Post. Were you guys surprised at the spot the impactor picked? And can you tell us briefly why you think it did choose that spot?
Yeah, it chose the brightest spot on the comet, and it performed the first two ITMs, and the last one it did the offset to pick that particular spot. The algorithms running on both the spacecraft, the flyby and the impactor, were both aiming at that specific spot, and that's where the earlier statement that the flyby captured this thing within 50 meters of the impact site.
Did you guys find that surprising? Given
We didn't know what to expect, because as we were going in, we were asking our optical navigation engineers, where's this thing going to go? And based on, as they were observing in real time the images, they were kind of saying, I think we're going down here, and that's where we ended up at.
In front.
Hi, Larry Evans with Mach 25 Media. I'm curious if you have any idea, recently, as you were making the approach, there were a couple of pretty good-sized outbursts on the comet. Can you characterize the outburst that was caused by the impactor in relation to the outburst that we saw naturally?
It was obviously a lot bigger, without a doubt. Beyond that, I can't say much. We haven't had enough time to look at the spectra or look at the shape of the variation of the brightness with time. And that there just requires a little bit more analysis.
Nicola Groom with Reuters. Was the size or shape of the comet dramatically different in any way from what you had been expecting?
Since we didn't know what to expect, it wasn't surprising. We knew from the shape of the light curve that there had to be something that cast big shadows, or we were pretty confident of that going in. And you actually saw that if you were looking at the images 6 hours before impact as we went in. I presume most of the press wasn't waiting with us for all 6 hours. You could actually see a very dark shadowed area come into sunlight very slowly and gradually brighten. So that was the kind of thing we expected. We expected it to be elongated, and we're going to have to go back and work on the stereoscopic combination of images to try to get the three-dimensional shape to find out if it's as elongated as we expected. Haven't had time yet to look at the topography to see if it's anything like either Comet Wilt 2 or Comet Borrelli.
Any more questions here? Yes, David Beck, again in the back.
One of the big unknowns going into this was what the fate of the flyby craft would be. Do you have any indications at this time? Do you know whether it survived completely intact, or when will you know?
It survived completely intact. After it went through the shield mode and came out the other side, we did a full health and status safety poll on it, and every subsystem was operating nominally.
And given the quality of the image, the look-back images, the optics survived beautifully also.
Any more questions here? Okay. Do we have any calls? Okay. Okay, I think we're going to call it a wrap then for tonight. You're all invited to come back later today for an update briefing that will be at 2 p.m. Eastern Time, 11 a.m. Pacific Time. And in the meantime, you can learn more about the mission, see the images, and at www.nasa.gov/deepimpact. You can also get more information on the mission at http://deepimpact.jpl.nasa.gov. And you can stand by for a replay of the images from this evening. Thank you so much for joining us.